So let's understand variables. So as just like in any other language, a variable is basically a location in memory where a value is stored. I'll show you I'll show you some examples of it. And what are variable names? As we just saw, variable names also follow the same rules of writing identifiers. For example, the moment I say a equals to 10, what's actually happening? And of course, I assign a value to a variable. Here, a is a variable, and 10 is the value that I give to this variable. So internally what's happening is in your RAM or in your main memory, you're going to get a memory location with value 10 stored in it, right? And the rules for, okay, for example, in this case, the rules for writing variable names, as we just saw a while ago when we were learning about identifiers, is any identifier name is okay for a variable name, right? It's just the same rules. For example, if I just go here and so I can't do this. So if I do this and run this, I get an error, right? I can't start it with a numeric character. I can't have special characters like hash. Oh, sorry, I can't have special characters like percentile, for example, right? So all the same rules of identifiers just hold here. Having said that, one thing that you'll quickly notice is, unlike C or other programming languages, we are not declaring a variable. In C, you would say int a, right? And then a equals to 10. Or you might say that int a equals to 10. So in C, what you typically do, sorry, you also put a semicolon here. In C, what you typically do is you declare the data type that a is a variable of type integer, and you have to declare it before you assign a value to it. Unlike that, in Python, you don't have to tell what data type it is, right? Python automatically understands that since 10 is an integer, a should be of type integer. So in Python, you don't explicitly have to say what is the data type of a variable, number one. Number two, you don't have to declare a variable before you use it. The moment you assign it, there is a new memory location called a created with an integer stored as 10. So this makes Python much more flexible. Of course, this has its own problems where people can get confused what the data type is and do some mistakes, but this makes Python much more easy to learn in general. Having learned this, so this is how you do simple assignment, right? In this case, this a is an integer, b is a float because you have 5.5, and c is a string. It's not a character, it's a string, right? Because there are two characters in here, right? So that's how simple variable assignment works. You can do multiple assignment also. This is very good. So instead of using 3 lines of code here, we can just do all of that in a single line. So for example, if I say a comma b comma c equals to 10 comma 5.5 comma ml, so the 10 value gets assigned to the first one here, which is a. 5.5 will get assigned to b, and ml will get assigned to c. Right? So in one line, you've declared, you have assigned 3 values to 3 variables. Right? So similarly, if you want to assign the same value to 3 variables, right? You want to assign the value ai to a, b, and c. You can just say a equals to b equals to c equals to ai. This makes life much more simple. In one line, you have assigned the value ai to 3 variables. Now comes a very, very interesting and very unique aspect of Python. Let's look at it. Let's look at it through code. Okay. So if I say x equals to 3, x is basically a variable which has a value 3, right? Now, when I say id of x, it prints the address or the memory location where x is stored, right? So where is x stored? X, it says, is stored at this location, 42976364116. Okay. So now your value 3 is stored in this memory location. Now, as soon as I do that, if I say y equals to 3, see here the same 3. And if I print the id of y, it actually gives me exactly the same value. So what Python does internally is, the moment you have done this, the moment you've assigned this, what Python does internally is, in this memory location, it basically stores a value 3 in your 4297 blah 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 416, this whole string here, right? And x now points to this location, right? The moment you're trying to assign y also to the same variable, y also starts pointing to the same location. Because of course, now if you change y will point to some other location, of course. But since you already have 3 stored, Python tries to reuse this memory elegantly, right? Now, for example, now let's look at it this way, okay? So the moment I change my y value to 2, right? The moment I change my y value to 2, its location again changes. So what's happening here is 3 is stored in my 4297636416 location. My x was pointing to this, my y was also pointing to this. The moment I said y equals to 2, it creates a new memory location, which is 4297636384, which is different from this location, and it makes your y point to this and remove this pointing, right? So this is done primarily to save memory when you have the same variable. Imagine instead of a small variable here, you have a big variable. You have a very bulky structure there, right? Then this saves a lot of space. Okay, now let's go and look at data types, standard data types. You can see you have int, float, double, etc. So let's look at similar ideas, right? So by the way, everything in Python has a data type. And for those of you who know object-oriented programming, everything in Python is an object. Everything in Python is an object. Everything is an object, which is important. Anyway, for those of you who don't know object-oriented programming, that's okay. We'll come to it when the time comes. But for now, let's just flow with some basics. Okay. So you have, okay. So let's look at a bunch of examples that makes life easy. So if I say a equals to 5, and if I print a is of type A. So this keyword type here, this word type here tells me what is the data type of a, right? So it says 5 is of type class int. So it's not saying it's of type int, because since everything is an object and Python is an object-oriented programming language, it says your 5 belongs to a class int. Or in other words, if you don't know object-oriented programming, it says it belongs to integer type. All right. Similarly, if I say a equals to 2.5, here I'm not saying that the data type of a equals to float or anything. It automatically understands based on the type of variable, so type of value that I'm assigning to a. So if I say the type of a now, I get class float. Similarly, just like your integers and floats in C, you also have complex numbers in Python. That makes life easy because complex numbers are extensively used in mathematical operations. Right? Math, physics, engineering uses complex numbers a lot. So if I declare a equals to 1 plus 2j, which means I'm assigning, this is a complex number, right? This is a complex number that I'm assigning to a variable a, right? Now, okay, if I just try to print a, I get a value like this, 1 plus 2j. And if I say, oh, then there is a very nice function which says, which is isInstance. What it says is, it is basically doing a Boolean check whether I plus 2j is a complex variable or not. Right? isInstance is a function through which I can check whether the data type of a variable is this or not. Right? So of course this returns true, it prints true because 1 plus 2j is a complex variable. Similarly, what I could have done here is, okay, let's just go and edit some code here. If I said print type of a here, okay, so you would get my output as class complex, right? So the type of a is complex, and that's what we just checked right now, right? So that's a very simple use case of isInstance, which checks what is the data type of a given variable. Now let's go and understand some other very simple data types called, one of them is called Boolean. So if I say a equals to true, so you have two Boolean variables, true and false. And by the way, both of them are keywords, true and false, with a capital T and a capital F. So if I say a equals to true, and if I print type of a, I get bool. So bool is basically a Boolean data type here. That's what it means, right? So now let's go down and understand strings, right? A string is nothing but a sequence of Unicode characters, not ASCII characters, Unicode characters, right? Which means it can store special characters, it can store it can store non-English characters. So strings in Python can store non-English characters, okay? Because Unicode is a much larger collection of characters, much larger than your ASCII. Those of you who don't know what Unicode is, it's okay, don't panic. You'll understand it eventually. Okay, so, okay, how do we represent a string? We can represent it using either a single quote or a double quote. For example, let's take this. So I said s equals to this is online AI course, and if I say print s, okay, let's just run this. Okay, I got this is online course. But what if I just say this, single quotes? Okay, it still works. Now if I say type of s, if we just say type of s, right? I get class str, which stands for string. So you can use either single quote. So for example, if I change this to double quotes, right? If I change this to double quotes, it's still string. And if I want multi-line strings, for example, if I want a string like this, right? So for example, s equals to ding ding, sorry. If I have a string which is multi-line, I can basically, so for example, if this string is multi-line, because this string spans 2 lines, right? So let me just show that to you. This string here, this is online with a backslash n here going to the next line. Of course, this is spanning 2 lines, right? So when strings span more than 1 line, you can use your triple quotes here, triple double quotes, or triple. You need to see 3 of them here, 1, 2, 3, surrounding them, and it'll still work. So let's just see what happens. So first, let's print s here. Okay. So when I print s here, I get my multi-line string here. And what is the type of s? Type of s will be just string. That's what I'm guessing. I hope that's true. Just a string. Instead of your 3 double quotes, I could have used 3 single quotes, right? Just let me make that small edit. Okay, and everything still holds, right? So a string here is basically a sequence of characters. You can have letters, strings, special characters, non-English characters, everything. And you can index. For example, suppose this is my string. If I say print s of 0, right? So again, in Python, everything is indexed with 0. So let me just show you an example. Let me just scroll up a little. Okay. So here, this is at index 0, t is at index 0, h is at index 1, I is at index 2, s is at index 4, the space is at index 5, so on and so forth. Just like in C, your strings are indexed, your indices for a string start with 0. So if I say print s0, right? If I just say print s0, I get capital T. If I say print s3, right? So print s3 gives me, because this is 0, 1, 2, the small s is there. Now the question is, how do you print the last character? There's a very nice hack here in Python. So you can just say -1. -1 basically means that you're going from back to front, right? So -1 gives me small e. What about -2? Let's just check that. -2 gives me s. So in Python, just the way everything starts with 0 here. This is 0, this is 1, this is 2, this is 3, this is -1, this is -2, and so on and so forth. You can also find the last element using a different way of doing it. So what I can say, instead of -1, -2, I can basically say, okay, I can basically say length of s -1. Okay, let's see what happens here. Okay, length of s basically is your whole length of the string. -1 basically here means your last character, right? So you can either use -1, suppose here, length of s basically tells me what is the length of s, right? So length of s basically tells me what is the length, and when I say -1, it refers to the last character here, which is e. Okay, but I prefer using this -1 notation here because it's much easier, because I always know what is the, if I want the last character, I'll just say -1. If I want the last but one character, I'll just say -2, and so on and so forth. There's another part, which is you can slice a string. Suppose if this is the string that I have, let's go look at a small example, small code snippet for that. Suppose this is my string. We do know that this is 0, 1, 2, 3, 4, and this is 5, right? So if I say string, okay, since I'm here, okay, so if I say 5 colon, it means print everything from 5 onwards, right? So this is an interesting notation. So what it says is, I want s, in the string s, I want everything from the 5th value, from index 5 to, the semicolon there basically means 2. So this can be read as, okay, from index 5 to everything else, to end, to the end, because you haven't put any number here, right? So if I run this code, if I run this small snippet, what it gives me is an online course. Of course, I have the \n because there is a new line here, because it's a multi-line character, right? So what if I say 5 to 10? Let's see what happens. Then it gives me the fifth character to the 10th character, which is from here to this. Okay, this is my 5, this is my 6, 7, 8, 9. It doesn't print the 10th character. Here it's not printing the 10th character, remember, because the 10th character is L, is the small l. It's not printing the 10th character. It's printing from the 5th character to the 9th character, the last but one. Okay, so this is how you slice a string. Basically, given a string, you're going to cut it and say, this is the part I want. This is like, think of it like substrings. Those of you who have used substrings in the past. There are other very, very interesting data types in Python, which you don't find in C and C++ by default. So you have something called a list. Okay, so let's understand what a list is. List is basically like your array, to put it very bluntly. Of course, list is far more flexible and powerful. But imagine, unlike your arrays, you can have multiple data types in a list. Okay, that's the most important thing. For example, here I'm declaring I'm declaring a list here as follows. Variable A is a list, and how do you write a list? You write it with your square brackets around it. And if this list has 3 elements, the first element, indexing again with 0, is 10. The second element is 20.5, and the third element is hello. Okay, again, indices start with 0 in Python in most cases. Okay, even in list here, if I say print A1, now this is how I define a list, right? I define a list using square brackets. That's important to remember, because there are other types of brackets which are used to define other data types, right? Now I can say, okay, this is the best part. Okay, so here I can say print A1, sorry, okay. So when I run this, so if I say print A2, if I print A2 here, what I get is hello, because this is index 0, this is index 1, and this is index 2, right? Remember, unlike your arrays, this is very, very important. Unlike your arrays, this is of type int, this is of type float, and this is of type string. So a list can have objects of any data type, doesn't matter. And another important thing is you can modify an element in a list. If you can modify an element in any data type, it's called a mutable data type. Those of you who have studied principles of programming language would recognize this term, mutable. Mutable basically means changeable, right? So for example, if we go and see this code here, I can say now my A1 initial, my A0 is 10, my A1 is 20.5. I can change my A1 to 30.7, which means I can change any element in my list, right? And when I print it, let's see what I get it. I can print my whole list actually, by the way. I don't have to print only an element. If I just say print A, your print command knows that it's a list and it will print it like a list, right? So even though we have this 1, 2, 0, 1, 2, I change the first element from 20.5 to 30.7, and that's what gets printed. Very, very simple. And lists are extensively used. Trust me, you'll see a lot of lists as we progress in the course. There is another data type called a tuple. So let's see what a tuple is. So a tuple, by the way, let's understand what is the difference between a list and a tuple first. A tuple is declared with the small braces, with parentheses, right? These are called parentheses, right? So this is how you declare a tuple, and your list is square brackets. So this is your list, right? So that's how you differentiate between a tuple and a list when you declare it. Again, just like a list, you can have multiple values. You can have 1, 1.5, and ml. All three of them are 3 different types. And you can access any particular element using the same indexing scheme. There is one fundamental difference between a tuple and a list, which is very important. You can't modify an element of a list. For example, if I try to run this code, okay, let's try to run this code. Okay, let's just quickly try to run this code. Okay, I'm running cell by cell. Okay, the moment I run this code now my running command is here. Suppose if I come here and if I run this code, okay, here what am I doing? My list, my tuple, at 0th element I have 1 element I have 1.5, second element I have ml. But if I try to modify, when I try to print, everything worked well. But if I try to modify my t1, which is this element, when I try to replace my 1.5 with 1.25, it said you can't do that. And let's read at the error. See, one of the very nice things with Python, it tells you exactly where the error happened. So it puts this nice arrow mark and it says, this is where the error happened. And it says, tuple object does not support item assignment. Very nice and very easy to understand. So Python, I really love Python errors because they're extremely easy to understand and know what's happening and how to fix even in some cases, right? So so what this means is that your tuples, unlike your arrays, are immutable, which means you can't change. So once you create them, you can't change just one element of it. Of course, you can delete your whole tuple if you choose to, but you can't change one element of it, right? So you can think of tuples as sort of like constants, right? Once you've declared it, or once you've assigned some value to a tuple, you can read it, you can do everything with it, but you can't edit any element of it, which is extremely important. Okay. Having said that, let's move to a different type of very interesting type of data type in Python called a set. Okay, and sets are declared. So now here A is a set, and sets are declared using your curly braces. So this is what is used for sets. Remember, this was for lists, this was for tuples, this was for list, this is for set, and this is for tuples, right? So now a set, so in this set, I have 5 elements, right? If I try to print A, I get all the 5 elements, right? Simple, it's a set. Set is basically, there are a couple of very interesting differences between set and lists and tuples. Let's go one by one. Okay, so if I say what is the type of A, it says it's a class set. Okay, as you would expect. But now comes the fun part with sets. Okay, the set data type behaves like a set in math, in your mathematics, right? For example, if I declare a set with 10 ones, there are 2 times 20 is occurring, 3 times 30 is occurring. But for a set, I don't care whether how many ever times a value repeats. If you try to print s, it actually stores 10, 20, and 30. So set only stores unique values. So this is like your set theory. If you remember your Venn diagrams and set theory that you must have learned in your high school, this is like those sets, right? And it's very useful when you want to do operations like set union. Suppose A is a set, B is a set. If you want to do the union or if you want to do the intersection of these sets, this is what a set is extremely useful for. Now comes the other interesting aspect of a set. Set is a unordered collection of items, which means if you try to print S1, it says, no, doesn't work. It gives you an error. So it says, so again, it tells you where the error is. That's the best part, as I told you about Python. And it says, set object does not support indexing. So it doesn't let you go to one element in a set. This is very, very important because set is an unordered collection of objects. It's not ordered. And hence you can't go to the first element. Even though these three look ordered here, this is not that, it's not that this is 0th element, this is first. No, that's untrue. How they're stored in memory. So which means you can't access it like this, right? How they're stored in memory is how the sets are implemented, right? You can't access a particular element in a set because it's an unordered collection of objects. Because that's what the set theory definition of a set is. A set in mathematics is basically a collection of objects which are unique and which are unordered, which means there is no ordering between them. Okay, having said that, let's go to a very interesting type of data structure in Python called a dictionary. Again, trust me, we will use dictionaries a lot in Python. Okay, so let's understand what a dictionary is. Dictionary is, you can think of it like storing a small table. Okay, a small table with 2 columns. Okay, let me explain why this is useful. Suppose you want to say, so the first one is called a key, the second one is called a value. Those of you who know data structures can imagine dictionaries to be like hash tables. Those of you who know what a hash table is, who have studied this in your algorithms course or data structures course, right? So if you don't know what a hash table is, don't worry. I'll just quickly give you a more simplified version of what a hash table is without going through all the mathematics and algorithmic details of hash table. So you can think of dictionary as a key value store. So the first one is called a key, the second one is called a value. So we all remember A for apple, B for bat, etc. as kids that we learned, right? So I can store my A for apple, A in the key, apple in the value. So now what happens is, so that's what I'm doing here. Again, your dictionaries in Python are declared using your curly braces, right? Just like your sets here, just like your sets. So if you go back, you'll see that sets also are declared like with the curly braces, okay? So just like, but there's a subtle difference here. You write your key first, this is your key, and this is your value. and you write key value pairs. So this is called a key value pair, right? Because there are two values. There is a key and there is a value. And you separate your key value pairs with a comma. So I could write D equals to A for apple, right? B for bat, C for cat, etc., etc. And now here comes the best part. So I told you that internally, in a very simplified form, it's stored like this. You have your key and you have your value. A for apple, right? B for bat, let's say C for cat, etc. And now if you say print D of A, here you're not using a numbering. You're not saying 0, 1 or 2. I can use the key to access that specific row in my table. That's the best part of hash tables and dictionaries. So this is your key value pair, right? You can access the whole row of information in your table using your key, right? So I can say, if I say print DA, see, I'm not using 0 or 1 here. I'm using the key itself, right? So when I say print DA, I get apple, just the way it's stored in my table, right? So if I say print B, what happens? I get bat. What happens if we print C? Okay, let's see. It gives you a key error. Okay, it gives you an error called key error, which means such a key is not present. Because in your table, as soon as you do this, it creates a table internally with A for apple and B for bat. And there is no C. So it tries to see if there is a row with C. And it immediately says, oh, there is no row with C, so there is some error here. Okay, so that's a very simple code for Python dictionary. Dictionaries are extensively used again. We will see them being used in a lot of places, not just in traditional Python programming, but also in data science. So lists, tuples, sets, and dictionaries are extremely useful in machine learning and data science in general. Trust me, we'll see them over and over again, probably hundreds of times through this course. Before we close out on this section of data types, let's also understand how to convert a data type from one type to other. Right? So here 5 is an int, right? Here 5 is an int. So if I say float of 5, it basically converts it into a float. So the float method, right, converts my integer to float. Similarly, if I have 100.5, this is float, right? This is a float data type. If I use the function int here, it will convert that into integer. Similarly, here my 20 is an integer. If I say str, it converts this integer into a string. See, if you look at it, you have the single quotes around it, right? So you can do simple conversion from one type to other type very easily. But here comes a very interesting boundary case. So what happens when I say convert my small word here, which is 10p into int? How do you convert 10p into int? You can't do that, right? So it immediately gives you a value error and says invalid literal, which means your p is not allowed here. That's why it's called an invalid literal. So for example, instead of p, if I just remove this, oh, then everything works good. I got an integer variable of type 10, right? But if I put any other value here, if I'm just putting p back here, it says it's not valid. That's not valid, right? Now comes, so let's write a very interesting print command here. Oh, by the way, Satish is one of our engineers who has helped me create these notebooks. Thanks to him. Just like every other person in our team. So let's assume I have a string user. So let's look at it here. Let's see why this is useful. So let's assume I have a string Satish, okay, and assigned to a variable user, and I have 100 in lines, right? So suppose if I want to write a code like this, which is print congratulations is a string, right? And I'm concatenating, or I'm adding at the end of this, I'm adding Satish, because user variable has the string Satish. So basically Satish comes here, right? Followed by, this is also a string, everything works well. Now lines here is an int, because 100 is an int, right? So for me to combine strings, right? Because everything till here is a string, but if I just have lines here, that's an int, right? So I need to convert it into string for it to work. So I just use the str function here, so that now your 100 becomes a string 100, right? As soon as we have that, now what we can do here is, okay, 100 lines, right? Now what happens is this. Now as soon as I run this, everything goes cool, okay? So as soon as I run this, everything goes cool. But let's say if I remove your str, I'm just removing my str here. Let's see what happens then. You immediately get an error. And as I told you, Python gives you very nice readable errors. Let me just go slightly up to explain you this. Okay, it says the error is at this line because it's marking it with an arrow, and it says the error is it must be a string and not int, and this is an int, and that's a problem with it, right? So let's go correct it again. So if I just say str, everything falls in place and just works, because now you're adding or you're concatenating. So this plus here is not your numerical plus, is not your mathematical plus, it's not your 2 plus 2. It's basically concatenating or joining your strings. Okay, now let's see some other examples, some very simple examples here. Okay, so let's go through this example. Suppose if I have a list A, right? So we know that lists are to be declared with square braces around, with square brackets around it. So if you say print type A, this thing prints list. Now can I convert A to a set? Yes, I can use the set function here, right? If I say set A, your S is now of type set, because if I print type of S, I get set here, right? So we can go from not just basic data types like int and float. You can convert your more complex data types like lists into sets and other formats. Okay. Similarly, if you have a string, hello is a string, right? Hello is a string, right? This is a string. Now, if I say list of hello, it immediately gets converted into a list where each character becomes an element in your list, right? So this is one way to break up a string into its component characters. Okay, with this, we have understood some of the basics of what data types exist. Not necessarily only the simple ones like int, float, and bool. We also understood lists, sets, and dictionaries. Very, very useful data types, as we will see throughout this course.